For this video, we're going to look at how we can use the Desmos graphing calculator to write an equation in slope-intercept form, but this time starting with just 2 points given to us. So we're going to start by typing the equation y equals mx plus b. And 2 sliders will appear, a slider for m and b, and the blue box, we're going to click on that, the one that says all. So we're going to get this line and with 2 sliders. But our task is to write an equation that goes between 2 particular points. So we're going to start a new line and we're going to type in the points. And we can type in both of them as long as we use parentheses and separate the 2 ordered pairs with a comma. So if we have the equation, the 2 points, what our first point is 2, 4, and we close the parentheses, comma, and then our new set of parentheses for our point 3, comma, -2. So we're imagining that we are given this particular set of ordered pairs, and so we graph each of those as well. So now we can see we have a line and we have 2 points. The problem is that's not the line that we need. So what we're going to do is we're going to play with the slider. So we already know that if I use slider B, it just moves the line up and down the y axis, changing what the intercept is. So I could move it so that it goes through 1 point. And then I'm going to use the slider for the slope, and we know that that's going to change how fast the line goes up and down or its steepness. So I know that if I go towards the positive, it gets steeper. And so it seems like it's going away from that point, the second point, and the first one we started with. So I might try the other way, and I'm going to keep doing that, and it doesn't quite seem to do what I need it to. So I'm going to keep playing with both the slope and the y-intercept. So I see that the 2 points, one is below the other. So I don't like how this is looking. So I'm going to think that the slope is negative. So I'm going to turn the line the other way and maybe have it go through that point. I also need to change my y-intercept because it needs to be closer. And now it's kind of in between the points. And so I'm just going to go back and forth, playing with the y-intercept and the slope until I get the line to hit the 2 points. So now I can go like this and get it closer to this point and then change my y-intercept. No, that's not working either. So I think I need it steeper even than that. And then play with my y-intercept. And that seems to be working. I need it to be steeper. And then play with my y-intercept. Oh, and so this one only goes to 10. So let's see. I could also just hit that, and it's playing with it. It's getting closer and farther away. Okay, so I'm going to stop that. Oops. Pause it. And I think I need it to go as far as I can, 10. And I need this to be a little steeper. Okay, and so it looks like it doesn't fit, right? So, but it looks like it's pretty close. So we have to use our imagination and some estimation. I'm going to try the equation y equals. So this looks like maybe it's supposed to be -4 because it's not quite right? It doesn't quite go through that point. And this was -3.8. So I'm going to try -4. And then we know we always need our x. And it looks like this red line, right here, it's going through 10, and that's not quite working for me. But 10 was the highest that I could go. So I'm just going to try 11. Okay, and that's a little closer. So to try 12 works. And that's going to be good enough. For what we're doing, that's as close as I'm going to get for this particular problem. And so it's an estimation, right? What we're doing is we're trying to get used to what happens when the slope changes, what happens when the y-intercept changes, and sometimes we're limited by the tools we have, but that's probably, I would accept like 12 or 11, right? That's pretty, that's as close as I feel like with this particular tool we're going to get. When I'm done, I can X out all these boxes and start with a new equation. But if I'm still doing the same type of problem, um, I might just wipe out the point and type it in a new set of points for the next practice problem, and then also X out this equation so that I'm ready once I get as close as possible to writing my new equation in slope-intercept form.